All right, so this is the first thing I wanted to call your attention to is under the learning modules. Remember Monday? Oh, you're just in time. So Monday I had mentioned that I'm going to have you do some assessments just to get some practice with different types of assessments that are out there, and also I'm going to have you write up your results into like a report form. So here I have a folder that has the assessments that should be completed before July 9th, because that will be the class where we start talking about some of the actual tests. So two of these are websites that you can go to. And actually this one, I think that, I don't know if you've noticed on Blackboard now, but it doesn't seem to like it if you go to content outside of Blackboard now. So sometimes it works better if you just right-click something and then open the link in a new window, which will take you outside of Blackboard. So this is the Authentic Happiness website. It's kind of a companion of the Authentic Happiness book, which is a book by Seligman, who's a big positive psychology guy. And you have to register to use this, but you can save information and come back to it, so that's the good part of it. And there's a specific questionnaire. Here's a whole list of questionnaires that you can take. And there's one in particular that I want you to take, and it's the VIA Survey of Character Strengths. And I have a, this will link you to this. So, and I think I have the username. So when, it doesn't look probably my email. Yeah, there we go. So, so this is a survey that has you kind of describe yourself and kind of gives you an idea of what your sort of your preferred character strengths would be. It doesn't really measure them directly, so you could say that you value intelligence, but it's not an IQ test. So I think it's probably really more of not a direct measure of what your character strengths might be, but what you would value as character strengths. Like what do you see as the most important ones to have, things like that. So that will be one. And what I'm looking for on this one is that you just pick your top 5 to report on. I'll have a checklist for all of this stuff later on for you. So that's that one. And then this one, this is the Big 30 test, which is kind of like the Big 5 personality. And on this one, all you have to do is put in your gender, and you click on it, and that takes you to a questionnaire. Now this one does not save your results, so you'll get a page that has sort of your profile, and that you have to print that out because you won't be able to revisit it. So if you forget to do that, you'll have to go back and do that one all over again. So good to remember that. This is a one-shot one, so you have to remember. Now there are a couple of things. Let's see, where I have to go back to where I was. I think that did let me follow the link, so now I gotta follow the breadcrumbs back to Blackboard here. Now there are 2 additional ones that they're tests that are on Excel files, although I can also put them on Google Docs. And I probably shouldn't say this on integrity, but I'm probably getting into a slightly weird copyright place with these, but it's just the online nature of the course. I don't really have any other good way to deploy these, so I would beg you not to reproduce these. Use them, get the results, and then So the Keirsey, some of you may be familiar with the Keirsey. It's a lot like the Myers-Briggs. I used to think that he ripped off Myers and Briggs, but then I realized, well, they're both ripping off Jung's. So the Myers-Briggs stuff is not proprietary at all. It comes straight from Jung's theories. And it's pretty self-explanatory. You have to just read the question, then you type in, and then you have, sort of a fourth choice between A or B. So you just have to type in A or B, whichever one applies. And then if you look down here, there's another tab. So if you click on the Results tab, it will actually give you your results as far as which of the 4 domains and what does that kind of come, what's sort of the overall descriptor of that. So you just need to remember what these words are for you. And if you're not familiar with the Myers-Briggs or the Keirsey, we'll be when it's time for you to interpret this stuff, we'll be talking more about it. So for now, all you really need to do is remember these results. Now you can save the test, and sometimes it's useful to go back and look at how you answered things when you're writing up the results. But so this one is one that you can download and you can save this. But please delete it when the course is over, because it probably has my name on it somewhere, and they'll come looking for me. They'll throw me in copyright jail. I mean, I think that if you put something on Blackboard, it's not like you're putting it out for the whole internet. So you do have a little bit more leeway. With like posting articles and things like that, but like I said, I think this is information, or this is in a form that we kind of have to be careful with. And I have one more that's like that, and this one actually is not quite ready to go yet, but this is a test called the CAD, and it's also an Excel file. And let's see, is it going to come up? I don't know, it doesn't seem to be coming up for some reason. But you'll kind of fill it out the same way that you did the Keirsey. There'll be a space for your rating. I think this one is a 5-point rating scale or something. So there will be a space for that, and there will be, a little thing that will tell you, what information to enter, whether it's a number or a letter or whatever. So that one's not quite ready, but that will be ready probably by tomorrow. So you can get going on these whenever you want, but try to get them done before we actually start talking about them. Okay, any questions about that? So you'll hear a lot more about these particular measures, but not until after you take them. All right, let's see. Was everybody able to access the content on Blackboard? I forgot to show you the movie with the cartoon squirrels in it, but it's posted now. So anybody watch it? It actually is a pretty good review of the stuff that we talked about, only with squirrels. So, and everything's better with squirrels, I guess. That must be the theory behind it. Okay, so any other questions or any other concerns before we go on to our next topic?
Those assessments, do them all by the 7th of May?
Mm-hmm. Yeah, and have your results, set aside. Okay, so I guess that brings us to our next part. Let me make sure I'm recording here. I guess I am. All right. Okay, so here's, remember I promised you that there'd be more statistical talk today, but that this would probably be about it. Reliability and validity are important things to understand when you're judging the quality of a test, and also when you're, when you're sort of fielding questions about test results and interpretations and things like that. So, it's an important part of understanding how tests are developed, how they're used, how they're interpreted, and what goes into all of that. So, in order to have an understanding of how reliability and validity work, it's important to have what's that? That looks like the last page. Why is that there? Hang on a sec here. That's weird. I'll have to edit this all out of Tegrity somehow. All right, there we go. So to understand reliability and validity, the only other statistical thing you need to have somewhat of an understanding about is correlation. Some of you remember correlation from other classes that you've had. Basically what correlation does is it shows how two sets of variables are related to one another. And these statistics really are the basis for determining reliability and validity. If you look at this scatter plot, you can see that there were, you can get a sense of how two data sets vary together by plotting them out. So what you're doing is you have one variable on one axis and the other variable on the other axis. So you plot a point that shows how a person, say this would be like a reading test, and this is an IQ test, for example. So if this is the reading test and this is your person of interest, you can go over here and say, well, they got almost a 3 on the reading test. And then you can go down this way and say, well, they got a 3 on the IQ test too. Here's a person who didn't do very well on either test. So it really, it's a way of showing in kind of like two-dimensional space how these two things relate. And this shows a positive correlation. And we know that if you're looking at IQ and reading, they do tend to be pretty correlated. So people who have low scores on one are likely to have low scores on the other. People who have high scores on one are likely to have high scores on the other. Although you can see it's not a perfect relationship. For example, somebody who has a reading disability might have high IQ scores, but they might have fairly low reading scores. So it's not a perfect relationship, but it is, you can kind of see that, well, that's the general trend, that yes, there's a relationship there and it's a positive relationship. Positive relation or positive correlation means a high score on one variable would yield a high score on another variable as a rule. So here's something that shows a negative correlation. So people who score high on the Y, whatever the Y thing is, people who score high on the Y tend to score lower on the X. And so high scores on one are associated with low scores on the other. Can you think of anything, real-life example of something that would have a negative correlation? How about age and video game proficiency? That would be one. Maybe that's not true anymore, but I think you would probably find that to be generally the case. The older you are, the lower the scores that you would have on, first-person shooter games, maybe. Now, sometimes there's no apparent relationship at all, and it will just look like random. You can't really discern a pattern in this. So you'd have to say whatever those two things are, they don't really have much to do with one another. So correlation is basically, it's a way of trying to find the line that fits the best through your data, and it shows the average relationship among the variables, and they try to find the line that fits the best so that you have the least ones that are kind of falling outside the line. It's a way of just minimizing the errors when you do that. The formula that's used for correlations is Pearson's R. And here's a definition of it. It's a ratio. It seems like all of these things are ratios of one kind or another. And so it's the degree to which x and y vary together divided by the degree to which they vary separately. So again, you're looking at, you throw the reading scores and the IQ scores together, and how much do they vary? If you kind of combine them, and then you can look at, well, how much variance does just the reading score have? How much variance does just the IQ score have? So if they share a lot of the same variation, then you'll have a number that's close together. So a high correlation would be a high number, and since it's a fraction, it's going to be less than 1. But so if you had a correlation of 0.9, that means essentially it means that they share 90% of the variation. If you have a low number, it means, well, they don't vary together very much. They don't share much variation. So R is the value of correlation. It can range between -1 and +1. If it's close to 0, that's when you don't have very much correlation between the two variables. If it's close to 1 or -1, then there's a really strong relationship between the two variables. You don't really see that too much in real life, where you'll have like really high correlations. You can also use this to make predictions. Like if you know in general, like what the correlation between reading and IQ is, and you know what somebody's IQ score is, you can kind of make a guess of what's their probable reading score going to be. Okay, I think I said all this already. So here would be some examples. The first one is pretty weak correlation. Again, you can't really discern much of a trend there. There's a really strong correlation. Maybe I should do this with a cursor for people at home. All right, because they can see me pointing, but they won't know what I'm necessarily pointing at. So this one would show a pretty strong correlation, and as you can see, it resembles pretty closely a straight line. This would be considered a fairly strong negative correlation, and you can see the trend there, but there's some scatter. And the same is true. This is a positive correlation, and this is a negative correlation. There's some scatter, but there's a definite trend there. And this would be a demonstration, again, of regression. I know this score. Look, I know this IQ score is about 102. So, and this is the regression line. This represents the relationship between the two of them. So I go out to where it crosses this line, and then I go down and say, well, I would predict it had about 100 reading score. You with me so far? Any questions? Okay. Now, the Pearson's R assumes that there's an underlying linear relationship between what you're trying to measure. For example, a relationship that can best be represented by a straight line. But not all relationships are linear. So for this to work, you really have to have that assumption that there's a linear relationship. Are any of you familiar with the Yerkes-Dodson law? Any psych majors? Basically, this is a pretty well-known law, and what it looks at is it looks at autonomic arousal, or you could say stress, and it looks at performance as a function of the amount of stress you have. So people who have a low amount of arousal or stress don't tend to perform that well. But then as arousal increases, there's sort of an optimal level of performance. But if you go beyond that with arousal or stress, then performance starts to drop off again. So you can see that this is kind of like there's a negative correlation and a positive correlation all in one relationship between these two variables. So the Pearson R wouldn't really work in a case like this. But I think for our purposes, we can usually get away with assuming that that there is a linear relationship between the two things that we're studying. All right, now I want to show you, should you ever have to do a correlation, I want to show you how you can, also want to show you with Excel how you can do one pretty easily. So first I have to get over to what, I think I shut that off. All the stuff that I had ready to go, I kind of messed up. Let's see. So I just need to go to Excel again. See, this is all the stuff I'll fix in post-production, and the people watching at home will think that I'm like really organized. Hang on here. This is an Excel that's running. No, I just messed up my... Let's get rid of that. There we go. Okay, so my last file was this one here. Okay, so the last time we met, we were talking about how many Facebook friends people had. And now I want to kind of use that data to do a correlation. But this time I'm going to ask you a slightly more personal question, which is, how old are you? And you can lie if you want to. I don't have any way of verifying your age. So I'll just start out with me. I'm 61, and I think I said I had about 23 Facebook friends. So how about you, Sheena?
25. It's at 250. 27. That's 500. 24. And I guess
252?
30.
Yes. Oops. 250. Okay. 28. 250. 14. Okay, so you see I have two columns here, and I can very easily get a correlation by using this formula that's up here. It says Correl, and then you have parentheses, and first you give the range of the first column, and then you give the range of the second column, and it does all that math for you. And what this is saying is that the correlation between age and number of Facebook friends is negative 66. So how would you interpret that?
The lower your age, the higher the Facebook group.
Mm-hmm. And would you say it's a pretty strong trend, or is it kind of a weak trend, or?
It's pretty strong because isn't -1 the highest low?
Yeah. Yeah. I'd say that's a moderately high trend. And that's kind of what I would predict. I was thinking that just yesterday when people were saying how many Facebook friends they had. And I do think that it tends to be the older you are, probably the fewer you have. Not because they all die off or anything like that. It's just because I just think probably just come from an era where there was a different definition of what constituted a friend. So I think that's not a surprising result. I think that if I were going to just eyeball that, I would say, yeah, there's probably a negative correlation there. So another thing you can do with this is you can actually have it plot out for you, do one of those scatter plots. What I did on this one is I converted both age and number of Facebook friends to z-scores so they'd be in the same units. So when you convert them to the same units, you can clearly see that here's a line and it has a negative slope, and actually the slope of the line is the same as the correlation if you use z-scores. So you can see that it's not it's not like a 45-degree angle, but it's a fairly steep line. So you can kind of visually see how it comes out on the scatter plot. And you can see we have a couple of outliers here too. This one, who is this? Is that you, Beth? Let's see, you had the most friends, right? Yeah. So you were the one who was probably the furthest from the line. So you're atypical, at least in this class, in this tiny population. But look at this guy over here, on the age. Whoever that is like way older than everybody else is. So there's an example. If you ever do need to do any correlations in real life, it's pretty simple to do with a spreadsheet, and pretty simple to make one of these scatter plots. It's actually built right into to Excel. You just ask it to make you a scatter plot. Let's see. Okay. So now let's go back to reliability and validity. You may recall from me reading that reliability is an indicator of how consistent your measure is. Do you tend to get the same results every time you make the measurement? And validity asks, are you measuring, that doesn't say the right thing, but are you measuring the right thing? Are you measuring what you think you're measuring or what you're trying to measure? So reliability is based on the classical test theory, and the idea behind this is that, well, there aren't any perfect measurements. It's impossible to totally eliminate measurement error because there's always going to be random elements that are going to get introduced into your measuring. So every score is a combination of true score plus there's some error. So what we want to do is see how close we can get to the true score and see if we can minimize the error that's there. Error would be random, uncontrollable things that happen, like an individual state of mind, when they take the test. You don't really necessarily have control over that. Sometimes I've gotten practically all the way through testing students and they'll tell me, man, I didn't get to sleep until 4 a.m. this morning. I was like, oh, that might have an effect on your results. Distractions, room conditions. I have an office in the middle school that's between 2 5th grade classrooms. And it's pretty quiet in the afternoon while they're all out doing specials, but there's no soundproofing at all. They might as well be in the same room with me. So I really try to avoid seeing people in the morning, especially if we're doing things that require a lot of concentration. When I took my GREs, it was back in the old school days when you didn't do it on a computer. And I was an undergrad at UVM, and we were about halfway through the GRE. And of course, because it was Vermont, there was a snowstorm going on outside, and the power went off. And they had to just throw those results out, and we had to start all over. So those are random, uncontrollable kinds of things that happen. Now, there are some types of error that you can prevent or control, and that would be a more systematic type of error. But if you think about it, if it's an error that's, say, there's a typo on the test. Well, everybody experiences the same typo. So it might not really affect things, although you can't be sure how it affects things. It's not measuring what it's supposed to measure if there's a typo that's sort of tipping off the answer to everybody. Or there could be an error. Sometimes there are errors, and you hear about this with SATs. They made a mistake with the programming, so there was an error in how things were scored. Those are systematic errors. And they can be avoided, and they should be avoided. A lot of effort, I think, goes into minimizing those types of errors. Those are the kinds of errors that you can avoid and should avoid. So more about a measurement error. So you have the true score, again, is what, in a perfect world, if you could measure without error, the measurement error is a component of the score that's a result of factors that distort the score from whatever its true value is. We can estimate what that error is. There's kind of you can kind of think of it in these terms. So you have a set of scores, and there's variance in it. And okay, so we know a part of that variance is due to actual differences in people and how they would perform. But some of the variance is due to these types of errors that are happening. So we know in the total variance there's some true variance and there's the error variance. We don't know how much is, what is what, but there are different ways of trying to estimate where the errors come in. And so reliability is looking at, it's another one of those ratios, how much of the true score variance or how much of the total variance is true score variance. So if you, again, with the same kind of ratio, like with the correlations, if you have a high number, if you have it's like, if the true score variance was the same as the total variance, then you'd have a score of 1, but that would be that's theoretically not likely to happen because that would mean you designed the perfect test. But if your true score variance, ratio of true score variance to total variance was 0.9, that means, well, there's only 10% error in here. 90% of this we can trust. If a reliability coefficient equals 0, the scores say, well, this test really sucks and you should get your money back because it's practically nothing but measurement error. As a rule of thumb, you would be looking for tests that would have reliability coefficients of 70.70 or 70% or greater to have acceptable reliability. The more important your use of the test, the more important that the reliability be as high as possible. Well, here's kind of a metaphor to illustrate this error. Suppose you had a box of chocolates, but you don't like the jelly-filled ones. But I don't like the jelly-filled ones. So if I got a jelly-filled one, that would be like an error. That would be an error in the sample. So the total variance is equal to the true variance plus the error variance. And so 100% of all of the chocolates, 88% of them would be tasty, and 12% of them would not be so good. Okay, so there are the chocolates, and there are the bad ones. So the reliability would be 21 good ones out of a total of 24. So 0.88, there would be an 88% probability that a random choice would be a good chocolate. Okay, it's the same thing, only with chocolate. Chocolate's even better than squirrels.
Did you say 70% reliability?
70 or greater, yeah. 70 would be considered a minimum acceptable reliability, because that's like saying, well, about a third of it's crap, but 2/3 of it's kind of okay. You really try to find the best reliability you can. Now, some types of things, you're just more likely to have errors in them. For example, when they do the SATs and they have you have multiple choice tests. Well, that's easy. Did they pick the right answer? But then they also have like a writing sample, and they're doing that according, different people are trained up to do it according to some criterion. Although I do think they're getting closer to having computers score writing samples, so that might reduce it. That might reduce the error somewhat, or at least make it more consistent. So a lot of it kind of depends on the test. Some tests it's easier to get a higher reliability than other types of tests. If there's subjectivity, then you're probably more likely to get more error built in. Oops. So these are some of the factors that influence measurement error. So transient states of the participants I mentioned. And that's something too, when I'm doing an evaluation, I always have to make a judgment of how comfortable the person is. If somebody's really uptight about it, then I'm probably going to make a statement in my report about, well, I'm not sure that this is the best reflection of their true abilities because they were very nervous about how they were doing, or something like that. And then again, I mentioned, the room temperature, lighting, crowding, noise, all of those kinds of things. Another thing that can happen is actual mistakes. Equipment can break down. People who are observing can make errors in recording. Sometimes people don't. You see this a lot with surveys. The people don't always understand the question, so they might answer it according to a total different interpretation of what they think you're asking for. Or people might write things down. Data entry errors. when I was in middle school, there's this like music aptitude test. Did any of you ever take the Seashore test? It's called the Seashore test, and it was multiple choice. You had to listen to this LP, and it would ask the questions like, okay, listen to this rhythm. Now, which rhythm was the same? And so it was multiple choice. I skipped one, so like all of my answers from that point on were wrong. That wasn't a very good assessment of my musical talent. So what kinds of things? And you know, it's not just on tests, but any information gathering process. You can kind of look at how reliable and how valid were your methods of gathering the information. So say you were interviewing somebody. What do you think would be some of the things that could affect the reliability of an interview? Yeah. Or motive. What's their motive? Are they trying to make a good impression or a bad impression? You know, if you want to get out on parole, you probably really want to make a good impression. If you're trying to convince people you're crazy and you should be discharged from the service, you're probably going to try to make a bad impression. What about if you were observing somebody? What could affect the reliability of an observation?
People pull out of class, talk to other students, and saw, a couple minutes rather than 30 minutes.
Right, so you might not have had a very good sample to go by. Yeah.
The fact that the student knows that you're there watching them.
Yeah, and that's kind of a classic one. That's the Hawthorne effect, which basically is that by observing behavior, you change the behavior that's being observed. And they discovered it because there were these efficiency experts that went to this factory in Hawthorne, New York, and when the workers were being watched by efficiency experts, they became very hard-working workers. So it kind of skewed the results. I see that a lot when I observe kids in a classroom, and a couple different things can happen. For one thing, a lot of times the teachers are nicer than I actually know them to be. And sometimes they'll say, well, usually I would have reined him in, but I want you to see how bad he can get. Now that's not a typical observation if you do that. Between the Hawthorne effect and, so the people being observed, anybody being observed, or just the mere fact that you're there. Now I always think about like the Gorillas in the Mist movie. Did you ever see that one? Who was it? Jane? I can't think of her name, but she wanted to study gorillas, and she just Jane Goodall, yeah, and she had to keep going back for weeks and weeks and weeks until the gorillas stopped. And after a while, the gorillas stopped noticing her. So then she could start getting more natural observations. But it took a long time before they got used to her because her just being there sort of changed the whole situation. Okay, so back to reliability, and looking at reliability as a statistical process. The reliability of a measure is in an inverse function of the measurement error. So the more error you have, the less reliable the instrument is. Think again of that ratio. 0.9 reliability means there's only 10% error in it. Reliable measures provide consistent measurement from occasion to occasion. There are different statistical methods for assessing reliability. So for example, one thing you would do is like, well, is this test stable over time? Does it always measure the same way? Well, we'll give somebody the test, and then we'll come back a week later, and we'll give them the test again. And we'll do a correlation between the two scores to see how different they are. Another way they look at reliability would be inter-rater reliability. So does this person who worked for Measured Progress do the same? Here's a writing sample. Let's see your score and let's see your score. and you do that, have several people do it, and then you look at what's the correlation there. Do the scores tend to match up for different people, rating different pieces of writing, or are they all over the place? So that's an important one if you have observations or things like that where there's some subjectivity. Internal consistency reliability is another way they can kind of look at reliability is, we'll split the test in half, and so if one half of the test correlates with the other test, then yeah, it's pretty consistently measuring the same thing. But the problem with that is that it might not be a very long test, so you might have a pretty small sample, and also there's no way to judge necessarily whether if you split it in half, whether the items are equivalent. There's a method called Cronbach's alpha, which statistically compares every possible combination that you can make if you split the test into two different parts, and then averages them all together. So they do a lot of stuff like that with statistics. All of those, they would all yield the same types of results, though. A high correlation would indicate that, yeah, it was a pretty consistent test. There's some problems with most of these methods, like test-retest. Couple things can happen. One is there can be a practice effect. So if you test somebody and then come back and test them a week later, they might remember, or maybe they said, I don't know what that word meant. I don't know what pluvius meant. I think I'll go look it up. The other thing is it assumes that the characteristic that you're measuring is stable over time. So you wouldn't do a reading test and test the kids in September and then come back and test them in January because, hey, they've been learning reading stuff in the meantime. That's also the case with like a personality test, for example. Some of those things you expect people to be kind of reactive to what's going on in their lives. So some types of personality traits or behavior, usually more behavioral type traits, you don't expect those to be really stable over long periods of time. Okay, so I already talked about inter-rater reliability, and when they do this, they don't know what the other people came up with, so of course it's like a blind test. And this is another reason why they put a lot of money into training. When they do these tests that are measured subjectively. Although there was an article in the New York Times a couple of years ago, sort of this expose of a guy who worked for the SATs or one of the other testing services, and he talked about how people would interact with what the kids wrote. Like, I think one of the questions was, what would you do if you had a lot of money or something like that? And one of the kids said, well, I would start a pornography business. And, it was pretty well written, but the person who scored it had moral objections to what they were saying, so they gave him a lower score. So things like that, there are a lot of things like that. Even when they've been trained, there are some things that can affect that. The other thing he talked about in his article was that they had just scored a whole bunch of these reading or these writing tests, and to celebrate they went out and got drunk, and then while they were out somebody discovered there was another like 800 tests that needed to be scored. So they came back and scored them all when they're drunk. So reliability is not all it's cracked up to be, even when things are planned and carefully, sort of designed. But I'll put that article up for you to read. It's actually pretty interesting. It won't improve your faith. Like, I know we had a lot of anti-GRE sentiment the other night. This will not improve your faith in the whole process. That's for sure. Okay, I already talked about this. Yeah, this is all things I got ahead of myself and talked about. So there are ways to increase reliability. As I mentioned, one of the things would be to have a very training of raters and having very specific objective criteria, like how many words did they write, how many complex sentences, things like that that are not quite so subject to subjective interpretation. Going through and getting rid of the easiest and the hardest items, because the easiest items, everybody got that one, so that doesn't tell you how people are different. And the same is true of the hardest ones. Oh, everybody missed that one. If you have one that if you're designing a test and everybody gets one right, the same one right, and everybody gets the same one wrong, you throw those out. Those just aren't good questions because they don't have any discrimination ability. Now, this shows confidence intervals on a standardized test. So sometimes parents say, well, why don't you just give me the number? Why do you have to hide it? You're trying to hide something from me here, aren't you? But usually when these are reported like this, it's to represent the possible error that's in there. So if you have a fairly reliable subtest, then it will be a narrower band, which means there's less likely that the scores will vary. This one here is kind of a special case for interpretation, though. You might conclude that, wow, that's a really unreliable test because look how much variation it is. But look at the scale. It's based on the normal curve. Remember that normal curve isn't equal units. So that just looks like it's unreliable because it's kind of at the top of the curve where the scores are a lot further apart. But that's the kind of thing that, again, like how do you expect parents to know that? Usually they don't even get the concept of confidence intervals. That requires a lot of explaining. Well, these confidence intervals are based on, guess what, a statistical measurement. It's called the standard error of measurement, and it's based on the reliability correlations that you get. And here's the formula for it. So in this case, S would be the standard deviation of an instrument. I think I told you that for IQ tests, the standard deviation has been set at 15. And then this is the square root of 1 minus r. So 1 minus r, remember r is the reliability, right? So if you throw out the reliability or subtract it from all of the information you have, that just leaves the error. So 1 minus r represents the error. But then again, you do a square root, like with to go from variance to standard deviation. You do a square root here just to get back to the units that you started with. So basically what you're doing here is you're taking the standard deviation of a test and you're multiplying it by the error that's in the test. And that gives you the standard error of measurement, which in a minute I'll kind of show you what you do with that. So for an IQ test with a standard deviation of 15, full-scale IQ test is pretty reliable, so 0.9 would be the reliability. And what that gives you, if you do out the math, is a standard error measurement of 5. And what that means is that the scores, the full-scale score on this particular IQ test is likely to vary between 95. Say if they got a score of 100, the score will range between 95 and 105. If you were to give the test many times, this is the likely range that of the variation that you would get based on what we know about the error that's in it. And the standard deviation also kind of puts it in the same units as the test. Okay, is that clear? Sort of clear? So a standard error of measurement, in a way, is kind of a normal curve inside of a normal curve. So if you look at the big normal curve, and that's telling you how much in a population, how do IQ scores vary. So that's the big one. And so that's the standard deviation. And, you know, it's based on the normal curve and has these proportions that we talked about the other day. 68% of the population will fall within this range. So the standard error of measurement is also a type of normal distribution. But what it's saying is how much will a particular score vary based on the error that's in the test. So we said there was a standard error of measurement of 5. So that means that 68% of the time, this score, let's say that's an IQ score of 100, 68% of the time it will vary plus or minus 5 points. If we took the test many, many times, the scores would fall in that range 68% of the time. 68% because it's based on the normal curve and normal probability. Okay, is that clear? It's a little, I think it can be a little hard to get your head around. They're both probabilities. The big one, the standard deviation is what is the probability that you will get a particular score. Standard error of measurement is what is the probability that the score that you obtain will vary a particular amount based on what we know about the error that's in the test. So these percentile bands are based on those standard errors of measurement. Now let me show you this thing. If you ever had a situation where you actually had to figure out a standard error of measurement. Hang on. See, now I'm having the same problem that I had before. It doesn't want to stay. Oh, okay, here we go. So this is a confidence level calculator that I made using Excel, and I'll put this online for you. So what it does is you can put in a score here. So say, okay, I want to know somebody got an IQ score. Let's say they got a score of 120. And we know that the standard deviation of that test is 15. And we know the reliability of the full-scale score is 0.9. So this calculates it. So what this says to do is look for the number in this box, and then take the square root of 1 minus the number that's in this box. So it does that same standard error of measurement calculation for you. So one standard error of measurement unit would be 4.7. So if you look over here, so if you want to be 68% confident of what the likely range of scores would be for this person, given the measurement error, is that 68% of the time the scores are going to vary between about 115 and 125. I rounded it up because we don't deal with like fractions of scores. We deal with whole units of scores. Okay, so 68% of the time is plus or minus 1 standard deviation. So it's this part of the distribution. Now if you go out 2 standard errors of measurement, that gives you 95% confidence. So here's 95% of the distribution, and that would be 2 of these, plus or minus 2 of these. So 95% of the time we would expect their scores to vary between 111 and 129. or you can be, real OCD about it and say, well, I have to be 99% sure that, the true score, that I'm hitting the true score somewhere in here. So you go out 3 standard errors of measurement on both sides, and then the range would be between 106 and 134. That's a pretty broad range. That's not even useful anymore. Usually for our purposes in doing evaluations in school, we usually use the standard error of measurement of 95% confidence, which is two standard errors of measurement. You can be, I think, 5% chance of error is pretty good. Pretty good that it's still a fairly reasonable range, but you are you're likely to be hitting their true score in there somewhere. Any questions about this stuff so far? Still with me? Okay, I'm trying to. So a measure can be valid for one purpose, but not for another purpose. For example, IQ tests. Some people think, well, you have verbal, nonverbal, kind of like the brain is organized. So maybe we can use IQ tests to determine whether people have, we can localize brain injuries with it. Well, it's not really made to do that. It wasn't the intention of it. It wasn't designed to do it. Maybe you can do it, but that's, you can't really claim that that's a valid purpose for an IQ test. You can claim that it's valid for getting an estimate of what somebody's cognitive ability is. And, the other thing about validity, and I think I kind of hinted at this, but really the more important the decisions you're making with a test is, the more it should have these technical qualities. The more reliable you would want it to be, the more valid you would want it to be. When we talk about personality testing, you'll find that some of the most commonly used personality tests don't have very good reliability or validity, and yet they're used to make very important decisions. I think if I had to go to court and testify about a conclusion I made based on one of these tests, and there was a lawyer who took Education 922 and knew about reliability and validity, you would have a very hard time defending the use of some of these commonly used tests, which we'll talk about more when we get to that. I think, would it be okay to use it to just sort of have some theories about what to work on with a client? Yeah, I think that would be fine. But that's not the same as making an important decision. I mean, they make custody decisions using these tests, whether you should get out on parole, all kinds of really important things, whether you should get a particular job. So if you're making important decisions like that, in some states, whether you get the death penalty or not depends on what your IQ is. So I'd say you probably want to, first of all, I wouldn't be the guy who does that, because I think that's an abuse of testing. But in some states, the idea is, well, if you have a low cognitive capacity, you don't know right from wrong, so you shouldn't be held responsible. You shouldn't have to face a death penalty. But what if you're 1 point over the cutoff? Knowing what we know about measurement error and things like that, that would seem like I'd hate to go to the chair because, of 1 point. So the more important the decision is, and I can't think of, something more important than a matter of life or death, the more important the decision is, the more you want to use measures that are reliable and valid for the purpose that they're intended. Now, how do reliability and validity relate to one another? A good measure has to be reliable, but it also has to be valid. And again, a valid measure measures what it's intended to measure. It can't be valid unless it's reliable. This is one of those, sounds kind of paradoxical, A measure can't be valid unless it's reliable, but a reliable measure may not be valid. And I have a good way of demonstrating that here. And just think of like archery targets. And so these are reliable, but they're not valid. It's like, well, gee, they pretty tight pattern there of hitting the target. You know, they were pretty consistent in hitting the target, but boy, they were just not really hit the bullseye at all. They didn't really cover what they were supposed to cover. About 3 years ago, I always used to use George Bush as kind of an example of somebody who was pretty consistent with his decisions, but I don't know if they were all necessarily, if I would think they were the right ones. Now this illustrates, well, this is valid. You know, they're hitting all the domains, they're hitting the target in all the places, but it's not reliable because it's not consistent. They're all over the place on the whole target. This is the worst one. They're neither reliable nor valid. They're all over the place and they're not covering all the things they need to cover. So this would represent both reliable and valid. The hits are consistent and they're covering, you know, the whole circle of what they need to cover. There are three types of validity for measurements. One is face validity. Then you have construct validity and criterion validity. Actually, there are more types than this, but these are sort of like the basic ones. Face validity isn't real validity at all. It's just if something's valid to the extent that which it appears to measure what it's supposed to measure. So, hey, it looks pretty good. That's face validity. It's not really a statistical process at all. It's just involves a judgment of the researcher or the participants. So a measure has face validity if somebody thinks it does. Now, just because something has face validity, it doesn't mean that it is a valid measure. And sometimes, in some cases, there are tests that don't have face validity that actually are good measures. If you think about it, if a test has face validity, if you look at the test and you think you know what it measures, then it might be easier to fake on the test than if it doesn't have face validity. Another pretty commonly used personality test is the MMPI. And a lot of tests, like questionnaires and things like that, say you want to measure depression. So you have a lot of questions about symptoms of depression. Have you had changes in your appetite? Do you have trouble sleeping? Are you sad a lot of the time? Have you ever thought of hurting yourself? Well, it would be pretty easy to figure out that that's what that test is getting at. The MMPI, they did a lot differently. What they did was they had two groups of people. One group of people were diagnosed as depressed, and one group of people didn't have any diagnosis of depression. And they just gave them huge numbers of questions on all kinds of topics. And what they did is they picked the questions that discriminated depressed people from non-depressed people and said that, okay, if you take the test and you answer like depressed people answer it, then you could be depressed. But the questions aren't necessarily about depression. I don't know if anybody's ever seen the MMPI. There's all kinds of crazy questions on there. You know, like I like mechanics magazines. When I was younger, I used to like to play, pin the tail on the donkey, whatever. Well, I don't know, maybe depressed people like mechanics magazines. I don't know, but you can see it's harder to fake because you don't know. You wouldn't know that, they're trying to find out if, I know what they're up to. They're trying to find out if I'm depressed. It's called the group contrast method as opposed to, the more straightforward, ask questions about diagnosis. It's a perfectly valid test. It's actually considered one of the better clinical tests that are out there. But they purposely made a test that didn't have so much face validity, because that way it's harder to fake your answers, either or for good or for bad. So face validity, don't be impressed if somebody tells you something has good face validity. Because it could have good face validity and actually stink, or it could have bad face validity and actually be a pretty good test. Construct validity, usually things that you're trying to measure have some type of hypothetical construct. Say, self-esteem, that's a construct. You can't necessarily always directly observe these things, but you can infer them from evidence that you might have. For example, intelligence. You can infer that somebody's intelligent. They may not be, but I think everybody has their own sort of personal theory of intelligence when they observe somebody to decide whether they're intelligent or not intelligent. Construct validity is assessed by studying the relationship between measures of a construct and scores on measures of other constructs. So, for example, construct intelligence as a construct. You want to see what's the relationship between, one thing you can do is what's the relationship between my IQ test that I just invented and this IQ test that's already out here. So you could correlate it with other measures of intelligence. You can correlate it with measures of achievement. Whatever your construct tells you is a basis for intelligence. And we'll talk about that, I think, next week when we talk about IQ testing. It's actually pretty interesting how they've tried to measure that. So we assess construct validity by seeing whether a particular measure relates as it should to other measures. If you do well on, if you get a high score on one IQ test, you should get a high score on another IQ test, for example. Why do we need two IQ tests if they both score the same? It's like anything else. It's like iPhones. Why do you need a new iPhone? You got to sell iPhones. Test companies have to sell tests. To have construct validity, the measure should have, it should correlate with other measures that it should be related to, and that's called convergent validity. And it should not correlate or should negatively correlate with measures that it shouldn't correlate with, and that's discriminant validity. For example, if you had a measure of self-esteem, somebody who scores high on a measure of self-esteem, you would expect them to score high on related measures. They should be confident, they should be optimistic, that kind of thing. But you would expect them to have, there to be a negative correlation between self-esteem and measures of insecurity and anxiety. That's assuming that self-esteem is a valid construct and that you're measuring it in a valid, in a way that kind of makes sense. Criterion-related validity refers to, can you use a measure to distinguish people on the basis of particular criterion? So an example of that would be the Scholastic Aptitude Test. It's valid to the extent that it tells you which students do well in college and which students don't do well in college. And actually, it's not a very good predictor of who graduates. It's a pretty good predictor of how you do in your first year of college. If, say, you have a test, a measure of marital conflict, that should correlate with behavioral observations. Like, wow, they have a really happy marriage, according to this questionnaire. So maybe, you could observe them and say, well, how many fights are they had? This kind of reminds me of, when I got married, we went to pre-Cana. Anybody here Catholic? So we had to do this compatibility test. And what we found was that we were very compatible with one another, but not so compatible with the Catholic Church. So I don't know. So as far as the validity of it as a relationship scale, yes, but I don't think it was necessarily show that we were had necessarily the same values that they would want us to have. Let's see. Oh, here's another one. So a measure of depressive symptoms. That's kind of, like what I was saying about the MMPI. Would you expect, a diagnosed group of people, diagnosed depressed people have very different results than people who are not diagnosed as depressed? Two kinds of criterion-related validity. One's concurrent validity, so the measurement criteria are assessed at the same time. All right, I want to know if this person is showing, depression right now. There's also predictive validity, so it's like, well, there's an elapsed time between when you give the measure and then you look at the criterion. For example, men's school admission test. Did this test do a good job of predicting who is going to do well in med school? Because that's one of the reasons you give it. SATs and GREs and PSATs is you're trying to, one, the concurrent thing is the person adequately prepared to do the work? And the other thing is, are they likely to be successful and finish school? Like I said the other day, GREs, terrible, just terrible. They don't have very good predictive validity at all. Maybe they have decent, criterion validity. Like I guess if you do pretty well on the GREs, that would probably indicate that you have what you need. But doing poorly on the GREs doesn't predict that you're not going to finish grad school or that you're not going to do well in grad school. I think grades are probably better predictors than these tests are. So yeah, here's my SAT example. Concurrent validity would be that high school seniors who score high in the SAT are better prepared for college than low scorers. I think that's probably true. But SAT scores predict academic performance 4 years later. Not so good. Not so good at that. Now, you may find yourself as school counselors of being in a situation where maybe you're on a committee, or maybe you're going to make your own decision about some tests or measurements that you want to buy. For example, there might be a vocational interest test, that you want to evaluate, or your school might be looking for some type of screening or performance measure. Nowadays, did you talk about response to intervention and all that in Kathy Condrello's class? There's kind of a move away from using diagnostic labels and more of saying that, kids' intervention should be targeted to what their needs are. So you have to determine, should they get their needs met in a regular classroom, or should they have a sort of kind of an extra boost, or should they be in a totally different place? And so a lot of what's involved in that is continuously monitoring their performance, so you can kind of identify problems when they come up, so you can intervene early with them. So I think there's just this trend, this continuing trend, where schools are going to do a lot of progress monitoring, a lot of intervention, a lot of program evaluation kinds of things. So it's very likely that there's not going to be more testing in schools in the future. There's not going to be less. There will probably be more. So it's good to be able to know, how do you know what's a decent test? And how would you evaluate it? You think about, how do you decide what phone to buy? You listen to advertisements. You read about the details, right, in catalogs and things like that. I have actually here's I'll pass these around. These are a couple different. I get about 1,000 of these around budget time, and I have my UNH address. I have 2 school addresses. I have my home address. So I just get massive quantities of these, and these are here you can kind of take a look through them and pass them on, but they're glossy, you know, and they want you to buy their stuff. It's very competitive, you know, like if you want to buy an IQ test, there's 2 or 3 or 4 different ones that you could consider buying. You know, so one way you can get information, and they all have websites. So one of the ways you can get information about it is to look at catalogs. Now, the thing about stuff that's being marketed to you is that they really want to make it sound like it's pretty good. You know, so it's probably not the most objective way of finding out about things, because it's marketing and they really want you to buy their test and they want to make it sound like a really good test. So it's a way to start. You know, you can sort of see what's out there. But the other thing that you might do if you're, you know, trying to decide what to buy would be to go to something like Consumer Reports, or go on Amazon and read like the star ratings, which I do a lot. They don't have star ratings for the tests on their websites. I can tell you that now. If you want to get objective information about tests, like if you want to get kind of like the unbiased Consumer Reports information about a particular test that you're interested in, there is a publication that you can use, and it's online. I'll show you. UNH has only had this for a few years, and I'm really glad they finally got it. Let me see. I'll go to the library. Here's the. Where's the? Shouldn't there be a tab for the library right on this first page? I guess I got it. Oh, here it is. Okay, library. So connect to databases. And you can just go to the quick find here. Databases. But there's a place to write one in. I can do this so easily when I'm not in front of an audience. I thought this was a box you could type stuff into. Just go to. All right, we'll just scroll down here. So. Here it is, Mental Measurement Yearbook with Tests in Print. It's part of the EBSCO. So at home, it let me go right to it. So why is it? Oh, here it is. Is that it? Okay, here we go. All right, so say you want to know more about, I want to know about behavior ratings. So I know that there's one called the BASC-2. So I'll just search for that. And so here are some write-ups about it. So what they are is they're kind of like movie reviews. They're independent reviews. So somebody takes the test home and they try it out. It's usually a professor, and they'll go through. They'll read the technical manual for you, and they'll look at how it was normed, and all of those types of things, and then they'll report back their conclusions about it. And usually, if you read a couple different ones, because you'll never find 2 psychologists that agree on something, so you have to read a couple. Well, the only thing psychologists agree on is that all other psychologists are jerks. They'll agree on that, but that's about it. So there's kind of some independent information that you can also look at that will help you as a consumer. So it's Consumer Reports for tests, and there are different ways to index this. You can look for particular types of tests, like, oh, I want to know about writing tests, or you can go by name, you can go by publisher, you can, maybe you just heard, like a lot of times people who use tests will refer to the tests just by their initials. like, oh, I gave him a WAIS. It's like, oh, I don't know what that test was, but I know it's WAIS. So you can look up tests by like their acronyms and things. So there's a lot of ways of getting at the information, and it's updated. I think it's a yearbook, so I think updated fairly frequently, and usually when something new comes out, it might be a year before there's a review about it. But I don't tend to be an early adopter of anything. Like when they came out with the new IQ test, there were a lot of problems with them, a lot of controversies about changes they made in them. So sometimes it's better to wait a year and let the early adopters find out that, and some of them aren't very good, but I think I mentioned before, you're talking about like, it could be a $1,500, $2,000 investment. So you really do want to, do a good job of vetting them and finding out, which ones are well regarded and which ones aren't. Another thing you can do, another way of evaluating tests, and the thing that has most of the technical information in it, would be looking in the actual test manuals. The kinds of things that you want to find out about in a test would be how big was the norm group? Did it seem like it was a representative sample? A lot of times they'll redo these tests every 10 years when they get the new census data, because it tells them like what types of samples, like how many what percentage of ethnic groups should we try to test, what population, what parts of the country geographically should we try to hit, what's the proportion of males to females, what are the proportions of different age levels. And they take all that information and they try to design a norming group that's very representative of the population of the country. And again, that's very expensive, which is one of the reasons, too, why the tests are very expensive. So you want to make sure that there's a broad and representative norm group. And then usually the test manuals will talk about, we talked about 2 or 3 different ways to validate a test, 2 or 3 different ways of determining validity. How did they do it, and what kinds of results did they get? So those are the kinds of things, that's kind of information that you would want to have to really judge whether a test was any good or not. So what I want to do now, I've brought some test manuals in, and this will kind of be like a scavenger hunt. Scavenger hunts are kind of fun, but other than that, I would just like that. So what I want to do is like, I have you pair up. Now, we'll have one group of 3. Maybe I'll give the group of 3 like the hardest one. But why don't you 2 take this manual? Give me just a second here. So this one's a career interest inventory kind of test. That's a brief IQ test. This is I'll have you 3 do this one. This is a projected personality test where did everybody get to look at catalogs? So that's a projected personality test where you look at pictures of hands doing different things and you try to come to some conclusions about the person. So, how the heck did they come up with that? So test manuals will have the reliability information. They'll have the normative data. How did they derive the norm groups? How did they validate the test? All of those kinds of things. We can also evaluate, well, is it easy to read? Is it hard to read? Is it bewildering? So here's the information that I want you to, where's my PowerPoint? Try to find this information. And then can report back to us what you were able to find out. And let's just take about 15 minutes to do this. So don't feel like you have to like totally go into depth and find every single little detail, but try to get kind of a general idea of how they developed this test, and also what you think the quality of it is. Would you buy this or would you not buy this? All right, and I'll come around and listen in and offer what help I can. And start with the table of contents, because that they should all have, like, you know, point you to this type of information.
It was a couple of different groups. So like one group was